Well, yeah, welcome to this tour of the Nevada Division. As was mentioned, this is a fictional line that runs from Caldwell, Idaho to Winnemucca, Nevada. In 1905, the San Francisco, Idaho, and Montana Railroad was formed. Headquarters were going to be in Caldwell, Idaho. The project failed after a few miles of grading were done, and I don't think any rails were ever laid. But the right-of-way was purchased by the Oregon Short Line and became the Wilder Branch, which still exists. Now, for modeling purposes, I assumed that the line was completed as far as Winnemucca and a connection with the overland route, and that it operated as an independent company until after World War II. At that time, it was purchased by Union Pacific and became the Nevada Division. The layout's a point-to-loop design, with the main yard and engine terminal at Caldwell, shown here, and a 5-track staging yard on a reversing loop at Winnemucca. It's single track with passing sidings and industries at 5 locations. I don't really have a track plan to show you, so we'll look at each of the towns in turn and then follow a train as it works its way from Winnemucca to Caldwell. We'll end with a few shots of the infrastructure of the layout. That is to say, the control panels, wiring, signal installation, etc. My focus is on operation. I'm not really a very good modeler, so highly detailed scenery and structures are not a priority for me. Fortunately, friends have contributed quite a few structures and helped with scenery. I've experimented with several eras during the life of the layout, but I'm currently focused on about 1960. Realizing that I'm fudging the end of steam operations by a few years. The layout is L-shaped. This is the long leg of the L. The space is about 29 feet long by 13 feet wide, although the width drops to 10 feet at the far end. There are 15 tracks in the stub end Caldwell yard. This shows the short leg of the L. The picture is taken from the same location as the previous one, but turned 90 degrees to the right. This part of the layout is roughly 13 by 15 feet. The total length of mainline run is about 320 feet. The turnouts are all Shinohara, and the track is Atlas Code 100 Flex Track. Construction started in 1983, so this is an old layout. Originally, the railroad was operated with a pretty sophisticated cab-controlled DC system with 4 mainline cabs and 2 yard cabs. In 2005, I installed NCE DCC. In 2011, I started a project to install operating signals using Dr. Bruce Chubb's computer model railroad interface. This is a view that visitors don't get because it required popping up through an access hole behind the roundhouse. It shows the Caldwell yard throat and some of the garden tracks around the turntable. Here's a close-up of the roundhouse and turntable. The roundhouse is a Hellion kit, and the turntable is diamond scale. Like many of my projects, I never quite finished the turntable, which lacks the operator's cab and the arch for electric power over the turntable bridge, but it works well. Indexing is manual, which takes a little practice. This is the engine servicing area. The coaling tower was built for me by Rick Uhlencott, MMR, and the 12-inch to the foot version of the 2295 is preserved on display at the Boise Depot, which some of you probably saw the last time we had a convention here. As I mentioned, my primary interest is operating in a semi-prototypical manner. In pre-COVID times, we had 2 operating sessions a month, each of which involved running 17 trains. Here's the westbound lineup ready to depart Caldwell. Even though the geographical alignment of the railroad is mostly north-south, we operate on an east-west basis, with Caldwell being the east end and Winnemucca the west end. Each operating session has 4 trains each way between Caldwell and Winnemucca, one of which is a through train that does no online switching. There are also two turns that go partway around the layout and then return to their originating points. Rome and Jordan Valley each operate two switch jobs, one before and one after the mainline trains arrive, to move cars to and from the interchange tracks. There is one daily passenger train in each direction. And finally, there is a Caldwell switch job that supplies the engine terminal with coal, oil, sand, diesel fuel, bunker C for the turbines, whatever. In this picture, you can see the Caldwell-McDermott turn on the far right. The turns operate with a back-to-back pair of GP9s, since there are no facilities for turning a steam locomotive on the line. Now we'll take a look at the various locations going west from Caldwell. The first town is Shaeville, which features a nice stockyard built by Dwight Williams, a Boise artist who also painted my backdrop. The backdrop ends just to the left of the water tank, so Dwight had the local high school kids decorate the tank to point out that, yes, Columbus was wrong. The world really does end right there. This is the drone view of Shaeville siding. You can just make out the stockyard water tank in the background. Shaeville is on a 2% grade, which is the ruling grade for the whole layout. People ask me sometimes about how often I need to clean the track. The answer is almost never. The room has a finished ceiling and floor, and regular operation keeps the track pretty clean. Even with very infrequent operations during the COVID pandemic, I haven't seen any big need for cleaning. Here is the town of Jordan Valley, Oregon. In addition to the main line, there is a passing siding and a track that serves 5 industries, and is also the interchange track where mainline trains pick up and set out cars. The actual spotting and pulling of the cars are done by a switch engine stationed at Jordan Valley. I found that having the road trains pull and spot cars really bogs things down, and it is much faster for the road trains to simply use the interchange track for pickups and setouts. The switch crew will then pull and block the cars before the road trains arrive, and then spot the setouts after the road trains have departed. And this procedure is also followed at Rome. This is the east end of Jordan Valley. The industry is American Millworks. The U-25B is slightly too modern for the railroad, having been delivered in 1962, but I can overlook anachronisms as long as I know about them. It's the ones that other people have to point out to me that bother me. Jordan Valley requires a powerful switch engine due to the occasional requirement to push 17 or 18 cars up the 2% grade and 30-inch radius curve just east of town. Here's the west end of Jordan Valley. The large building is Leviathan Publishing, which receives paper and ink and ships books and magazines. There's a team track behind the flatbed trailer, and on the right are Get Her Done Warehouse and almost hidden the S&W fruit packing plant. This is Rome, Oregon. It's the largest town between Caldwell and Winnemucca. Like Jordan Valley, it has a passing siding and an interchange track and a dedicated switch engine. It's flat, so an SW7 can handle the switching duty. The City of Winnemucca passenger train stops twice a day at the depot, once in each direction. Rome has a grain elevator, a freight house, a fertilizer plant, an icing platform yet to be built, a team track, and a house track on each end of the depot. Here's a closer look at the east end of Rome, showing the Water Street Terminal freight house and the Miller Brothers elevator, another unfinished project which needs to be painted. You can see evidence that the track serving Water Street had to be relocated to make room for the signal protecting the east end of Rome. The next town to the west is McDermott, which is right at the border between Oregon and Nevada. This shows the east end with the interstate oil fuel distributor. This is the west end of McDermott with the Armour meatpacking plant. On leaving McDermott, trains enter a long stretch of hidden track until arriving at Orovada. The industries here are a grain elevator, a scrap yard, and 2 freight distributors. The tracks continue to Winnemucca through the tunnel on the left. Winnemucca is represented by a 5-track wide reversing loop. Trains normally proceed around the loop in a counterclockwise direction, which leaves the engines visible when they stop, as shown here. Here we see the eastbound trains ready to depart. We'll follow Extra 3940 East, the Challenger with its headlight on the trip to Caldwell. We'll have a relatively unimpeded trip. If this were a real operating session with 4 to 6 people running trains, there would be several delays for traffic. We don't have a dispatcher, and we rely on negotiation to get rights to occupy track. Sometimes I'll have to make decisions about who gets to go and who has to wait. Before we start our eastbound trip, let's take a look at the manifest, or the switch list, for the train. I use the Operations Pro component of the Java Model Railroad Interface, JMRI, to generate traffic. Operations Pro does a great job of matching car types, possible loads, and customer requirements to keep traffic flowing. One neat feature is that it keeps track of the number of times a car has moved, and when it has a choice of several cars to satisfy a move, it selects the car with the lowest move count. This makes sure that all the cars circulate. This is the manifest for train WMCW1, the first Winnemucca Caldwell, which today has the 3940 for power. All freight trains run as extras, so we'll refer to the train as Extra 3940 East as we go along. The top portion in green shows the pickups at Winnemucca. I set up the trains manually before each session, so this represents the starting consist as we leave Winnemucca. If you look just below the Winnemucca section for the scheduled work at Orovada, you'll see that we have 2 pickups in green and 3 setouts at Orovada in red, also all at Nevada Fast Freight. Okay, here's Extra 3940 East arriving in the siding at Orovada. Our pickups are the first 2 cars on the spur to the right, the white boxcar and the State of Maine boxcar. And our setouts are the first 3 cars behind the engine. Work is now completed and the train is ready to leave Orovada. Notice that the white boxcar that was on the spur is now the first car of the train. The dwarf signal is green and the train is about to enter the long stretch of hidden track that leads to McDermott. Okay, here's the manifest again. Looking a little farther down the page to scheduled work at McDermott, you can see that we have 2 pickups at the meatpacking plant, empty stock cars, and 1 set out at Interstate Oil, a boxcar of fuel additives. Extra 3940 East has now arrived at McDermott, where we will be picking up 2 empty stock cars at the meatpacking plant. Loaded stock cars have to be placed on the head end to minimize risk of injury to the animals from slack action, but empties can be placed anywhere in the train. We'll put them next to the caboose for the olfactory enjoyment of the rear end crew. We're also setting out a boxcar of fuel additives at Interstate Oil. Here we've cut away from the train and are going to make the set out. McDermott's on a 2% grade, and our cars don't have handbrakes or air brakes. So we have a simple, crude, but effective means of keeping the cars from rolling down the hill. Somewhat similar to the clamps that Bob used in his presentation. The motor car and shed was a gift from 3rd Division Superintendent Tom Waters, who also supplied a number of other structures around the railroad. Thanks, Tom. Okay, here's the manifest again. And looking right down at the bottom at the work at Rome Interchange, you'll see that we're picking up a B&O boxcar from the interchange track and setting out a Western Fruit Express reefer on the same track. Our train has pulled into the siding at Rome and is ready to start switching. The B&O car to be picked up is behind the covered hopper on the interchange track. Our set out is the yellow reefer, 3rd car in the train. Switching is now completed and we're ready to leave, but we have to hold for the westbound City of Winnemucca, approaching its station stop at the Rome Depot. Here's the second page of the switch list. At the top, you can see it says no work at Jordan Valley Interchange. So we'll just go right through Jordan Valley. At Shaysville, we're picking up 2 cars of cattle, setting out an empty stock car and a boxcar load of hay. No work at Jordan Valley, so extra 3940 East blasts right through town, but slows for a diverging approach signal at the west end of Shaysville. And now we see the reason for the diverging approach signal. Extra 9035 West is holding the main, and the dispatcher has routed our train through the siding. No matter, the stockyard can be switched from either the main or the siding. Now we're beginning the switching at the stockyard. We'll be picking up the 2 stock cars at the loading pen and setting out the empty stock car and the box car, the 4th and 5th cars of our train. Some extra moves will be required because the setouts are not arranged correctly. The box car will need to be spotted at the hayloft, while the stock car will have to be behind it at the loading pen. Note that again, we have to use our trusty clothespin to hold the train on the grade, because the grade here is again about 2%. So you have to look closely now, because this looks almost like, this next picture looks almost like this one. But you'll see that we're backing onto the train now after the switching is done. The 2 loaded stock cars that we picked up should be on the head end, but the conductor has decided that they're close enough to the head end that the slack action should not be too great. And then over on the left, you can see that the box car is now at the hayloft and the stock car is at the loading pen. Well, we're on the home stretch now. Extra 3940 East is passing the intermediate signal between Shaysville and Wilder. The scenery in this area was built by noted modeler Joe Fugate and his wife Patty when they lived in Boise. It's still the best scenery on the railroad. The yardmaster has given extra 3940 East a diverging approach signal to enter the yard, indicated by the red over yellow aspect. The next signal for extra 3940 East will be a lunar on the signal bridge at the end of signal track, indicating that the train must proceed at restricted speed, prepared to stop within half the distance to any obstruction or misaligned turnout. If all is well, the yardmaster will have routed the train into an empty track. The train has arrived at Caldwell and the engine has been cut off. Next, the yard switcher will tie onto the caboose, pull the train away, and move it to another yard track. Then the hostler will turn the engine either on the turntable or more usually on the balloon track to get it pointed in the right direction for its next trip west. We'll finish this tour by taking a look at some of the infrastructure that makes the layout work. When I first built the layout, the control panels were necessary to switch block power among the 4 mainline throttles and also to throw the turnouts. The DCC conversion eliminated the need for block toggles, but the turnouts are still thrown from the panels. This is the mainline panel for the east end of the railroad, from Caldwell to Rome. From right to left, the locations are Caldwell, Wilder, Shaeville, Jordan Valley, and Rome. This is the west end mainline panel. From right to left, again, we have Rome, McDermott, Orovada, and Winnemucca. You can see the 5-track reversing loop at Winnemucca on the left. The square voltmeters and ammeters are a relic of the DC days and are now unused. Similarly, the 3-position rotary switches were used to connect other throttles to this panel and are also now redundant. This is the panel used by the Caldwell Yardmaster. The yard tracks are designated F1 through F7 and P1 through P7, reflecting an original idea to have roughly equal freight and passenger operations. Passenger traffic has dwindled and most of the yard is now used for freight. The tracks that meet in a V on the upper left of the panel are the turntable leads. Above and to the left of them is the balloon track that allows equipment to be turned. Arriving passenger trains, of which we still have one daily, use the balloon track to back into the station. Here's an underexposed shot of that same panel so you can see the LED lights that indicate turnout position. This is the other Caldwell panel. It's the same as the Yardmaster's panel, but turned upside down since it's on the other side of the yard. The rotary switches and toggles at the lower right are the controls for the turntable. This shows how the panels fold down for access. This is the back side of the east end mainline panel. And here's the backside of one of the Caldwell yard panels. There's a lot of labor here that wouldn't be required in a layout initially designed for DCC. All those little red things are block toggles, which are now totally unnecessary. The layout was designed for walk-around control. The DC throttles that I used had a walk-around capability. So I installed push buttons to operate the turnouts at various points around the fascia. This is a shot of the fascia where Orovada is on the lower level and Rome is on the upper level. So you can see that I've put the turnout number labels at slightly different elevations. That there's 2 on the left that are closer to the lower edge of the fascia. Those are for turnouts at Orovada. And the other 3 are a little bit higher up. Those are for turnouts at Rome. I had always been interested in having working signals. I read Dr. Chubb's articles in Model Railroader when he first introduced the CMRI system and you know, had all the plans for making the circuit boards yourself and building them and everything. And I found the complexity more than I thought I could handle. I didn't think I could build that stuff. But at the 2011 NMRA National Convention in Sacramento, I attended a clinic by Dr. Chubb on the CMRI system and was rather pleased to find out that assembled and tested circuit boards were available. So I decided to go ahead with the project, and I now have operating signals. I haven't taken the next step to have a complete CTC system with a dispatcher, maybe someday. Actually, I'm not sure where I'd find room in the computer room for a dispatcher's panel, but I mean in the train room, but maybe someday. Anyway, here's a train looking at a proceed signal, even indicating that the next 2 blocks are unoccupied. And here's the view in the opposite direction, showing that the block protected by the signal is indeed occupied. Some of the signals are located pretty close to the aisles, so I decided I had to protect them with these transparent shields. They're not very nice to look at, but they've already saved several signals from being knocked over. You wouldn't believe how easy it is to swing an elbow over the edge of the fascia there and bump into a signal. The wiring is centralized at 3 panels, one near each mainline control panel and one under the Caldwell yard. Each one contains the circuitry for one node of the CMRI system. This is node 0. The CMRI SUSIC card and a bunch of input-output cards are at the top left, and the DCC optimized detectors are the yellow cards at the bottom right. The other connections are for track power and for turnout power and turnout position detection. This is node 1, the panel under the Caldwell yard. You can also see some of the RIX twin coil switch machine mountings hanging down from above. Motor drive switch machines were just becoming available when I started the railroad. And at that time, my recollection is that they did not have enough contacts, auxiliary contacts, to route power as much as I needed to do. So I would love to change over to motor drive machines now, but I don't have the flexibility to work under the layout like I used to. And plus my eyes aren't very good. And some of those machines are in pretty hard to get at places now that everything is finished. So they're probably going to stay twin coil for the life of the layout. This is node 2 of the CMRI system. In its original form, the railroad had about 60 blocks. There are now 10 power districts with PSX circuit breakers, plus 2 automatic reversers, one for the balloon track at Caldwell and one for the reverse loops at Winnemucca. You can see 4 of the PSX units and 1 of the reversers in this picture, and also a whole bunch more of those DCC optimized detectors. And of course, on the upper right is another SUSIC with all the IO cards for this end of the railroad. Well, I have a frog in my throat from all this talking, so this will complete our tour of the Nevada Division. I hope the next time we have a convention here in Boise, you'll all be able to come and see the railroad in person and maybe do a little operating. Thank you very much for watching. Okay, Russ, back over to you.
Thank you, Joel. Outstanding.
Thanks, Joel. I've got a couple of questions that come in. What's a house track? You mentioned it several times.
House track is a track typically at a depot where they could park cars with supplies, or sometimes they would, you know, a lot of times in passenger operations, they would in the middle of the night they would stop and pick up a sleeper that you know, people could get on the sleeper and go to bed at 8 o'clock, and then about 1 in the morning or so, a train would come pick up the sleeper and take it on its way. And a house track was used for that. Typically had steam connections available for heating and so forth for passenger cars.
Okay. Another question, what do you use for signal masts?
For signal masts, did you say?
Correct.
Those were built by a company down in Utah called Custom Signal Systems. They're really nice. I like the colors. There's 3 tiny little LEDs in each one of those searchlight heads, and the colors seem to be pretty prototypical to me for the way the searchlight signals actually looked.
Sounds good. What's the inside and outside radius on your 5-track reverse loop for the staging yard?
I think the inside is 30. And the outside would be, let's see, I think they're 2.5 inches apart. So
5, 10,
about 40 for the outside.
Okay. Do you use fast clock on your operations? And if so, what's the ratio?
You know, we really don't. I planned on it. I even built a fast clock from an article in a 1983 model railroader, but I never could get it to work reliably. And so we don't really use a fast clock now. The you know, NCE system has a clock built into it that you can use, but we don't use a fast clock. It would be kind of hard to keep the traffic flowing because of the occasional backups, traffic tie-ups, I guess you'd call them, when we have you know, 5 or 6 people operating. And so it's more in the nature of sequential operations rather than according to a time schedule.
Okay.
Thank you. Yes, always flexible.